Hello everyone, can you all hear me? Okay. Hello everyone, our project is on the growth and life cycle of Akita domestica's crickets in a microgravity environment for astronaut consumption. My name is Abhinav Ajish,
And my name is Jacob Castro.
and our other co-investigator is Nawal Siddiqui, who couldn't be here. And our teacher facilitator is Miss Mary Smith.
The essential question to our project is, how does microgravity affect the life cycle and development of the crickets, and most importantly, their protein makeup for astronaut consumption?
So why crickets? Crickets have one of the highest protein contents of any protein sources. This is higher than goat, pork, chicken, or even salmon. And Akita domestica's crickets have the highest protein content of any cricket. In addition to that, these crickets also have high amino acid levels, which is essential for maintaining muscle and overall health, especially in space. Crickets can also be bred in space as a food source for long-distance space missions due to their space and cost efficiency.
Our experimental design will use the Type 2 FME Mini Lab. Volume 1 will house 10 cricket eggs, a sponge, cotton, water, and some dog food. The second volume will house 2 milliliters of formalin to officially end the experiment. This design will be replicated and manufactured at the same time to establish a ground truth experiment, and that will run parallel to the in-orbit experiment.
To determine the effects of microgravity on these crickets, they will be weighed and measured as soon as they reach our community. Since all variables are consistent between the space true and ground true experiments, we can conduct a Keldev protein analysis. This is to determine the protein composition between both the space and ground true examples. And this will be used to determine whether or not space-grown crickets can be a viable food source for astronauts. The Keldev protein analysis essentially mimics digestion using sulfuric acid. The end result is nitrogen, and this nitrogen will be measured and used to estimate the amount of protein in the crickets.
So, to gather eggs, we've been farming crickets for around 6 months, using containers filled with peat moss to collect the eggs. However, we have had, unfortunately, multiple setbacks, including premature cricket death before they could lay eggs. We've also had sterile crickets. We have had the loss of eggs due to humidity, heat, dehydration, gnats, parasitic mites, and fungus. However, luckily, we have been seeing positive develop in the newest batch of eggs.
Our sample list is pretty straightforward. We have 10 cricket eggs, 2.5 milliliters of purified water for the crickets to use, as well as 1 ounce of crushed dog food. This will be what the crickets eat throughout their duration on the ISS. There'll also be a sponge, which the cricket eggs will be in. The sponge will have a little bit of water, just to maintain the moisture for the cricket eggs. There'll also be a cotton ball. This will be used to keep the purified water, the rest of it, in place through the duration of the experiment. And in volume 2, there'll be the formalin to officially end the experiment in space to prevent any tampering of gravity.
Alrighty. When compared to the ground true experiment, we expect the space true crickets to have a lower protein content and size due to the microgravity. The lack of gravity may result in reduced muscle development, which would affect the overall protein content of the crickets.
In the coming months, we'll decide whether or not to continue breeding the eggs in-house or to buy them directly from a vendor. We'll also start setting up the mini labs and running preliminary ground experiment trials to test the viability and tweak some of the mixtures. We'll also prepare and send the tubes for launch, as well as conduct an initial Keldev protein analysis on the crickets. We'll also need to find a lab, specifically in one of the colleges that we are attending, to help us do these protein analysis on the crickets. This will be just to identify whether or not we can do the protein analysis on the crickets and get a viable estimate of what the protein is in these crickets. In conclusion, we will also write a research paper on our findings for future use on space missions or even on Earth.
Alrighty, we would like to acknowledge the Hollyfield Science Learning Center and thank them for all the time they dedicated to us for help breeding crickets. Plano ISD Academy High School, Dr. Gashin, Ms. Gunnels, Mr. Michael Hardy, Ms. Smith for helping us throughout this process, and Toyota Motor North America for help funding our community into SSEP.
Thank you so much for your time. Let us know if you have any questions.
Hi, great presentation. I just have a question about when you use radiation on the eggs, will that change the genetic makeup of your crickets, and will that like alter so you don't have replicates anymore?
So originally we were using crickets from Costco from Petco to get the cricket eggs, but they treat their crickets with radiation. That was the problem. That's why all our eggs weren't fertilized. So we've switched to a new brand, which is specifically for breeding crickets. So we won't have the problem with the radiation anymore. And the eggs that we have will be essentially natural cricket eggs.
Okay, thank you.
Any other questions?
Have either of you consumed crickets? And if so, do you have any comments on how they taste?
I personally have. I've had chocolate crickets and normal crickets, and I mean, they taste all right. They taste good. You?
So the main thing about crickets and eating them, you can eat them whole and fried, but the main issue is the stigma around eating a bug. But that can be easily solved by powdering the cricket into a paste. Then you won't have to see the cricket while eating it.
Yeah.
Thank you so much.